Imagine opening your microwave. You punch in 2 minutes, you hit start. Simple, right? But the moment you press that button, you are pulling on this invisible thread that stretches across the entire globe.
Yeah, and it is a profoundly fragile thread. I mean, one that connects your basic kitchen appliance to a highly calibrated laser in Germany, a vacuum chamber in the Netherlands, and a heavily guarded factory on an island in the Pacific.
Right. When you really trace that thread, you realize that the popular conception of technology it's completely backwards.
Yeah.
You might think of tech as social media apps or, search engines or the software running in the cloud.
Which is what everyone thinks of.
Exactly. But the actual technology running your life, from the smartphone in your pocket to your car and even your refrigerator, is physical. It's the semiconductor. And that is why today you and I are putting on our investigative tech journalist hats.
We definitely are.
We're doing a deep dive into a massive stack of research centered primarily around the book Chip War by Chris Miller to really understand this hidden reality.
Because we need to cut through a global supply chain so complex, it makes a spider web look like a straight line. The mission here is to uncover why the global economy, and actually the military balance of power, currently hinges on these microscopic pieces of silicon. We need to understand the mechanics of this invisible war.
Yeah, and I have to say, my first hurdle with this topic was just wrapping my head around the scale of our addiction to these little chips.
It's hard to visualize.
It really is.
Yeah.
To understand the stakes, we first have to visualize what a transistor actually is. So think of a transistor as a tiny electrical light switch. It flips on to make a 1 and off to make a 0.
Right, binary code.
Exactly. Billions of these microscopic switches flipping on and off together create the entire digital universe. They, convert images, sound, radio waves, and logic into 1s and 0s.
And the scale is almost beyond human comprehension. The sources note that in 2020, the chip industry produced more transistors than the combined quantity of all goods produced by all other companies in all other industries in all of human history.
Wait, I want to make sure I'm fully absorbing that. All goods.
All goods.
Meaning if we took every car, pencil, brick, and, I don't know, pair of shoes ever made since the dawn of humanity, the number of tiny silicon switches made in a single year outnumbers them.
By orders of magnitude, actually. Let's look at a very specific example from the text to ground this. For Apple's A14 chip, which was the brain inside the iPhone 12, a single manufacturing facility in Taiwan called Fab 18 fabricated well over 1 quintillion transistors in just a matter of months.
1 quintillion.
Yeah, that is a 1 with 18 zeros behind it.
That is just staggering. It makes perfect sense why Jerry Sanders, the flamboyant founder of AMD, famously declared back in the 1980s that semiconductors are the crude oil of the modern economy. He really saw the trajectory.
His foresight was remarkable because today, China actually spends more money each year importing semiconductor chips than it spends importing actual physical oil.
More than oil.
Yeah. Just like oil in the 20th century, if a nation's supply of chips is cut off today, their entire economy just grinds to a sudden and catastrophic halt.
And it goes far beyond consumer electronics or, the broader economy. It is the absolute backbone of national security. The research points out this massive historical evolution in warfare.
Right, the shift in military strategy.
Exactly. World War II was largely a contest of industrial mass, who could forge the most steel and aluminum into tanks and bombers. The Cold War that followed was defined by atomic weapons and the threat of nuclear annihilation. But today, the rivalry between superpowers is fundamentally determined by computing power.
And the U.S. military realized this decades before most of the public did. Starting in the mid-'70s, under Pentagon officials like William Perry, the U.S. developed what became known as the offset strategy.
The offset strategy, how did that work?
Well, the dynamic at the time was that the Soviet Union had a massive conventional advantage in Europe, like far more troops, far more tanks. The U.S. recognized they couldn't win a war of sheer numbers, so they decided to offset that Soviet numerical advantage with extreme precision.
Okay, so instead of building 10 dumb bombs, you build one smart bomb that never misses.
Precisely. They instructed defense firms to pack their planes and rockets with as many chips as possible. That push for computing power is what built the early F-14 fighter jet computers, highly advanced radar, signal jamming systems, and, eventually the autonomous drones we see today.
Okay, let's unpack this, because here's the part that still trips me up. If these are essentially just microscopic switches, why are they considered the ultimate strategic resource today, dictating the fate of nations?
It's a fair question.
I mean, human beings figured out how to split the atom 80 years ago. Why can't a wealthy nation just build their own factories to make their own switches?
Well, the bottleneck lies in the physical reality of how we make them. As the demand for more computing power grew, the industry had to squeeze more and more of these switches onto the exact same size chip.
Right, Moore's law.
Exactly. But the physics of shrinking those transistors down to an atomic scale became mind-bogglingly difficult.
Here's where it gets really interesting for me. Because if making these things requires that level of impossible physics, it makes you wonder how the entire world ended up relying on just a few companies to pull it off.
It's an incredibly concentrated industry.
Extremely. The global supply chain has bottlenecked into a terrifyingly fragile monopoly. We are looking at a system deeply reliant on incredibly specific choke points. Let's start with the fabrication itself, centered in Taiwan with a company called TSMC.
Yeah, TSMC, or the Taiwan Semiconductor Manufacturing Company, was founded by Morris Chang. And he turned the company into an absolute global powerhouse by adopting a completely novel strategy at the time.
What did he do differently?
Well, TSMC doesn't actually design the chips. They operate as a neutral foundry, manufacturing chips for everyone else. Apple, AMD, NVIDIA. Chang called this ecosystem the Grand Alliance.
Okay, wait, I need to clarify that relationship because it's crucial. If a company like Apple is considered a fabless designer, what are they actually doing? Are they just drawing blueprints and sending them over?
It is essentially a hyper-advanced form of architecture. Fabless designers spend billions of dollars writing the complex logic and structural blueprints for how those billions of switches need to be arranged to process AI or render graphics.
But they don't make them.
Right, they do not own a single factory. They hand those digital blueprints over to a foundry like TSMC, who has the incredibly specialized equipment to physically carve those microscopic blueprints into a wafer of silicon. In the Grand Alliance, the fabless designers, the equipment makers, and the intellectual property providers all coordinate around TSMC's manufacturing standards.
And what happens inside those TSMC factories sounds closer to magic than industrial manufacturing. We mentioned Fab 18 earlier, carving 11.8 billion transistors onto a single iPhone 12 chip.
The density is just insane.
It really is. To achieve that density, they are etching microscopic mazes into silicon that are smaller than half the size of a single coronavirus, 100th the size of a mitochondria. How do you even paint lines that small? I mean, there is no physical needle or brush on Earth capable of that.
No, there isn't. You have to use light, specifically extreme ultraviolet light, or EUV. And this introduces us to perhaps the most critical choke point in the entire global economy, a Dutch company called ASML.
The only company that can do this, right?
Literally the only one. They're the only company in the world capable of building extreme ultraviolet lithography machines. Without ASML's equipment, manufacturing cutting-edge chips is simply impossible.
I had to read the explanation of this machine in the research 3 separate times because it reads like pure science fiction. You can't just, buy an EUV light bulb at the hardware store. To generate this specific wavelength of light, the machine shoots a microscopic ball of molten tin traveling at 200 miles per hour through a vacuum chamber with a laser. And it doesn't just shoot it once, it hits it twice.
The precision required is breathtaking. The first laser pulse hits the tin droplet merely to flatten it out into a pancake shape.
To make it a bigger target.
Exactly, maximizing its surface area. Then the second, immensely more powerful pulse blasts that flatten tin into a plasma. And the machine has to repeat this exact double pulse process 50,000 times per second just to generate a steady stream of EUV light.
50,000 times a second. That is absurd.
And when that tin turns to plasma, it reaches a temperature of 500,000 degrees, which is many times harder than the surface of the sun.
This isn't manufacturing. This is like trying to paint the Mona Lisa with a laser on a canvas the size of a molecule.
While the canvas is moving. And the complications go even deeper. Because extreme ultraviolet light has such a short wavelength, it is much closer to X-rays than visible light. It gets absorbed by almost everything it touches, including air.
Oh, so that's why this all happens in a vacuum chamber.
Precisely. But it also means you cannot focus the light using traditional glass lenses because the glass would just absorb the light. So to direct that EUV light onto the silicon wafer, ASML relies on a series of specialized mirrors from a German optics company called Zeiss.
The details on those mirrors blew my mind. The research notes that Zeiss builds these mirrors out of 100 alternating layers of molybdenum and silicon, with each individual layer being just a couple of nanometers thick.
The engineering is flawless.
It has to be. The smoothness is absurd. If you took one of these mirrors and scaled it up to the size of the entire country of Germany, the biggest bump or irregularity on the surface would be 1/10 of a millimeter.
It's hard to even process that level of perfection, and ASML serves as the grand orchestrator of this impossible symphony. They don't build every single part in-house. They manage a finely tuned network of thousands of highly specialized suppliers.
Right.
A single EUV machine costs well over $100 million, requires multiple 747 cargo planes to ship, and contains hundreds of thousands of components.
So, given this level of extreme engineering, how did the supply chain get so hyper-concentrated? My initial thought reading all this is if a superpower like the US or China recognizes that this machine is the key to global dominance, why don't they just write a trillion-dollar check and build their own version? What is physically stopping a massive government from just replicating this technology at home tomorrow?
Well, a blank check cannot buy time or deeply specialized accumulated knowledge. No single country possesses all the necessary puzzle pieces.
Too fragmented.
Exactly. The extreme metallurgy, the fluid dynamic software, the high-powered lasers, the flawless optics mastering these took decades of relentless global cooperation. I mean, an ASML machine features specialized parts from Cymer in California, lasers from Trump in Germany, and those flawless optics from Zeiss.
So you'd have to catch up on 50 years of R&D in multiple different scientific fields all at once.
Right. Attempting to reproduce that deeply entrenched global symphony in isolation would require reinventing thousands of individual wheels simultaneously.
If the underlying technology requires this intricate web of global cooperation just to function, it seems completely counterintuitive that nations would try to wall it off. But that perfectly sets up the geopolitical reality we are living in today.
It really does.
Both the US and China have recognized that whoever controls these microscopic choke points controls the future of the global economy and military dominance.
We are witnessing a profound geopolitical shift. The era of free-flowing, hyper-globalized tech supply chains is essentially ending. Both superpowers are actively maneuvering around these exact vulnerabilities, weaponizing the supply chain against each other.
And to be clear to you listening, we're not taking a side here. We are just looking at the strategic maneuvers outlined in the text. Let's analyze the U.S. strategy first, what the text refers to as the chip choke. The U.S. Commerce Department made a sweeping, unprecedented move against the Chinese tech giant Huawei.
The mechanics of how the U.S. executed this are fascinating from a strategic standpoint. Initially, the U.S. simply restricted American companies from selling U.S.-made chips to Huawei.
This is straightforward enough.
But in a globalized world, Huawei could easily bypass that by designing their own chips in-house and simply paying TSMC in Taiwan to manufacture them.
Right, because TSMC isn't American. So the U.S. essentially rewrote the rules of global trade. They invoked something called the Foreign Direct Product Rule,
Which is an incredibly powerful legal tool.
Yeah, it basically says that if a foreign factory, like TSMC in Taiwan, uses any American-made technology, tools, or software in their chip-building process, and because of the nature of the supply chain, they absolutely have to, then that foreign factory cannot fabricate chips for Huawei without begging for a special license from the U.S. government.
The U.S. basically leveraged its dominance in the obscure foundational layers of the supply chain. American companies dominate the core software used to design chips, as well as many of the physical tools used inside the clean rooms.
So they choked off the tools, not just the final product.
Exactly. By weaponizing those specific tools, the U.S. extended its jurisdiction globally. Huawei suddenly found itself entirely cut off from the world's advanced chip-making infrastructure, despite TSMC being a Taiwanese company. We saw similar U.S. blacklistings happen to other major Chinese entities, like SMIC, which is China's most advanced domestic chip foundry, and Fidium, a company designing chips for supercomputers.
From Beijing's perspective, the research shows this is viewed as an existential vulnerability to their economy and their military modernization. Chinese strategists often talk about the Malacca dilemma.
Right, the fear that their access to foreign oil could be easily blockaded by the U.S. Navy at the Strait of Malacca.
Yeah, but Beijing is now facing a modern blockade, one constructed out of export controls and software licenses rather than warships. It's measured in bytes rather than barrels.
Which is why the Chinese government is responding with staggering investments. They have launched what is known as the Big Fund, pouring tens of billions of dollars into achieving domestic semiconductor self-sufficiency.
They're trying to build their own ecosystem.
They're trying to forcefully incubate their own versions of ASML and TSMC, devoting their best engineering minds to breaking free from this reliance on Western choke points.
So what does this all mean? Looking at the components we just spent time marveling at, the American lasers, the German mirrors, the Dutch orchestration, the Taiwanese fabrication, is a truly decoupled tech world even physically possible? Or are Washington and Beijing locked in a state of mutually assured supply chain destruction?
The consensus in the research suggests that complete decoupling is an illusion, at least in any short to medium time frame.
It's just too intertwined.
The technology is simply too expensive and intricately interconnected. If China or the US attempted to build a purely domestic, cutting-edge semiconductor supply chain completely from scratch tomorrow, it would take decades of trial and error.
And while you were spending 10 years in isolation trying to invent your own extreme ultraviolet laser from scratch, the rest of the world hasn't stopped. They have already collaborated to solve the next impossible physics problem, leaving you a decade behind again.
Exactly. The system's very nature demands massive global cooperation to function at the absolute cutting edge. Yet, the current geopolitical climate is forcefully demanding isolation and domestic security. It is an unstoppable political force meeting a highly engineered, unmovable physical object.
So if decoupling is a fantasy, and both superpowers desperately need these microscopic switches to power their futures, what happens when the geopolitical tension reaches a boiling point exactly where the chips are actually made? I am talking, of course, about Taiwan.
The physical geography of the supply chain is genuinely terrifying when you look at it on a map. Taiwan, and specifically TSMC, produces 37% of the world's logic chips.
That's a massive chunk.
These are the crucial brains of our computers, our phones, and our cars.
And these factories aren't tucked away in some heavily fortified, geologically stable bunker. The sources highlight that TSMC's major fabrication plants sit directly on the Chilungpu Fault, which famously caused a devastating earthquake in Taiwan in 1999.
That alone is a huge risk.
But even more pressing than the tectonic plates, they sit right across the Taiwan Strait from mainland China, well within easy missile range.
This concentration of vital manufacturing has birthed a geopolitical concept heavily promoted by Taiwanese President Tsai Ing-wen, known as the Silicon Shield.
The Silicon Shield. What exactly is the premise there?
The underlying theory is that Taiwan's absolute dominance in advanced chip manufacturing actually protects it from authoritarian aggression. The logic assumes that an invasion or a military blockade would instantly sever the global supply of chips, causing a worldwide economic apocalypse that would hurt China just as severely, if not more so, than the rest of the world. Therefore, the semiconductor industry acts as a deterrent shield.
I really struggle to buy into that theory. Having the world's most indispensable and physically fragile factory sitting in the middle of a geopolitical flashpoint sounds a lot less like a shield and a lot more like a ticking time bomb. Does this concentration actually deter war, or does it make Taiwan an irresistible target?
The sources grapple extensively with this exact contradiction. The Silicon Shield theory fundamentally relies on every geopolitical actor behaving completely rationally, prioritizing economic stability above all else.
Which history tells us isn't always a safe bet.
Right. TSMC's leadership argues that nobody wants to disrupt the supply chain because peace is highly profitable for everyone. But if you analyze the real-world stakes of losing that manufacturing capacity, if those fabs go offline, whether by a blockade, an invasion, or even a severe natural disaster, the fallout is catastrophic and instantaneous.
We got a tiny, almost trivial preview of what that looks like during the COVID-19 chip shortage. I vividly remember President Biden holding up a tiny silicon wafer in a Zoom meeting with the CEOs of Ford and GM because American auto factories were literally shutting down for weeks.
They couldn't finish the cars.
Yeah, they had the steel, they had the tires, but they couldn't finish the cars because they lacked a 50-cent chip. The 5G network rollout ground to a halt. Cloud data centers couldn't source the servers they needed to expand, and that was just a temporary logistical hiccup.
Imagine multiplying that hiccup by 1,000. If Taiwan's fabs slip into the fault line or are knocked out by conflict, 37% of the world's new computing power simply vanishes overnight.
You can't just flip a switch in another country to replace it.
Not at all. A third of all PC processors would be gone. There has been a recent political push to onshore fabrication, like TSMC building a new plant in Arizona. But the sources are crystal clear on this. The absolute most advanced, cutting-edge technology always remains firmly anchored in Taiwan.
It feels like an illusion of safety. We talk a big game in the U.S. about securing our supply chains and bringing manufacturing home. But the sheer gravity of the ecosystem in Taiwan, the tens of thousands of highly trained engineers, the localized network of specialized chemical suppliers, the established rhythm of the Grand Alliance, it just keeps pulling the center of the technological universe back to that one specific island.
Humanity has inadvertently placed its most complex, fragile, and economically essential industry on one of the most geopolitically unstable pieces of real estate on the planet. And the tension stems from the fact that neither superpower feels they can afford to let the other control it.
It really is a hostage situation where
Mhm.
the ransom is measured in nanometers. The global economy is completely dependent on a miracle of engineering that could be disrupted by a single stray missile or a shift in a tectonic plate.
It is a delicate, miraculous web that we rely on for almost every single aspect of modern existence, from communicating with our families to deploying military assets.
We set out today to understand the real tech war defining our era, acting as your guides through this incredibly dense geopolitical forest. And I think it's safe to say those invisible strings we talked about at the start, they are everywhere.
Absolutely everywhere.
The next time you pull out your smartphone, or start your car, or even just look at your microwave in the kitchen, I want you to imagine the invisible connections tying that mundane device to microscopic tin droplets exploding in the Netherlands, utterly perfect mirrors polished in Germany, highly calibrated lasers designed in California, spotless clean rooms humming in Taiwan, and the quiet, high-stakes war rooms in Washington and Beijing trying to control it all.
It is arguably the greatest triumph of global engineering and efficiency in human history, but it is simultaneously our greatest shared vulnerability.
But I want to leave you with one final, mind-bending thought to chew on after you finish listening. If the physical limitations of squeezing silicon transistors closer together are finally maxing out, if we are reaching the absolute edge of what lasers and molten tin droplets can physically do, what happens if a nation completely bypasses silicon altogether?
That's the real unknown.
Right. What if, driven by this intense geopolitical pressure, someone invents an entirely new paradigm, like a stable quantum computer or advanced biological computing? Would the country that achieves that breakthrough instantly render this entire trillion-dollar global supply chain and the current geopolitical map completely obsolete overnight?
That is the ultimate wild card in this entire narrative. A single scientific breakthrough in a lab somewhere could instantly rewrite the rules of global power, making the chip war look like a fight over steam engines.
And just like that, the invisible thread you pulled to start your microwave might suddenly snap or transform into something else entirely. Keep exploring, keep questioning everything around you, and we'll see you on the next deep dive.